Do you know how a TV or phone screen is measured? They're measured on the diagonal. Hopefully you can see the connection to the Pythagorean theorem. The diagonal is actually the hypotenuse of the right triangle. If you think about it, why isn't your 48-inch TV 4 feet wide? Why does a 7-inch tablet seem so small? When retailers give you the size of a screen, they're giving you the length of the diagonal, not the width of the screen. It may seem odd that we measure screens in terms of diagonals. After all, we give the size of most rectangular objects in terms of length and width. The diagonal measurements are left over from the first television screens. The earliest screens were actually circular, so manufacturers began measuring a screen by its diameter or the distance across the circle. Before we start applying the Pythagorean theorem to real-world problems, let's practice rounding decimals. Round the decimal to the nearest tenth. Most students struggle with place values when dealing with decimals. You might remember from the beginning of the year, we talked about this little trick. You put a 1 underneath the decimal, and then you write out however many zeros you need to fulfill the value you are rounding to. Since we are rounding to the tenths place, we want to write the number 10. So we'll write 1 0 after the 1, and that means our 9 is in the tenths place. So you might remember we talked about this again at the beginning of the year. 5 or more, add 1 more, 4 or less, let it rest. So the 2 next to the 9, we have to decide, is it going to bump it up or is it going to leave it alone? Since 2 is less than 5, our answer is going to stay 4.9. Let's practice one more example before we start solving real-world problems using the Pythagorean theorem. Round the decimal to the nearest hundredth. So let's do what we did in the previous example. Let's go ahead and put a 1 under the decimal and write out until we see the number 100. So that means the 4 is in the hundredths place. So we're going to look next door. We're going to look to the 7, and that will help us decide, is that going to bump it up or leave it alone? 5 or more, add 1 more. 4 or less, let it rest. Since 7 is 5 or more, we'll go ahead and add 1 more. So my new decimal answer will be 23.55, or the proper way of saying it is 23 and 55 hundredths. Now let's start applying the Pythagorean theorem to real-world problems. A ship leaves port and sails 5 kilometers west and then 23 kilometers north. How far is the ship from port? Round to the nearest tenth of a kilometer. Sometimes word problems don't give you any visuals, so you might have to draw your own. I created a little animation to hopefully help us visualize what is happening. So our boat has to head 5 kilometers west. And then it's going to move 23 kilometers north. Now we need to determine how far the ship is from the port. We're going to draw a straight line going from the port to the ship. Now you can see how the Pythagorean theorem will help us solve this problem. Our right angle is always directly across from our C value. So once we determine the C value, we'll know how far our ship is from the port. Let's go ahead and write down our formula. A squared plus B squared equals C squared. I'm going to label 23 as my A value and 5 as my B value. And let's go ahead and plug in those numbers. 23 to the second power plus 5 to the second power equals C to the second power. You can type the entire left side of this expression into your calculator. 23x to the second plus 5x to the second, and then hit equals. You should get 554, and that's equal to c squared. Remember, we always need to make sure our answer does not have that exponent of 2. So we have to take the square root of both sides. The square root of c squared is c, because an exponent of 2 and a square root symbol cancel out. And 554, take the square root, you get a long decimal, but we're just going to write out 23.53. We want to round our decimal to the nearest tenth. So if we follow what we did in our review, we'll put a 1 under the decimal and a 0 under the 5. So the 5 is in the tenths place. So 5 or more, add 1 more. 4 or less, let it rest. Since 3 is less than 4, we'll go ahead and determine our answer is 23.5 kilometers. Let's look at another word problem. A square table in the cafeteria has the dimensions shown. What is the length of the diagonal of the table? Round to the nearest tenth. If we look at the diagonal, they gave us one of the side lengths of 8 feet. In order to determine the other side lengths, we have to remember what a square table means. Well, a square has the same lengths on all sides. So if one side of our square is 8 feet, that means each side of the square is equal to 8 feet. And hopefully you can see we have 2 triangles we can choose to solve. I'm going to choose this triangle here. So if you notice, our right angle is directly across from our C value. So we are still looking for our C value in this problem. Let's go ahead and write down our Pythagorean theorem. A squared plus B squared equals C squared. So since A and B are the same number, it doesn't really matter where you plug them in, but I'm going to go ahead and label my A and B on my triangle just to keep it consistent. A equals 8 squared. Our B value is also 8. And that will help us determine our C squared value. So if you type 8 squared plus 8 squared into your calculator, you're going to get 128. Remember, you always have to take the square root in your final step. We always want to get rid of this exponent next to c. So we'll take the square root of 128 and the square root of c squared. Well, the square root of c squared is just c, since an exponent and a square root cancel each other out. And 128, take the square root, will give us a long decimal, 11.313, blah, blah, blah. We want to round this problem to the nearest tenth. So let's go ahead and put a 1 under the decimal, a 0 under the 3. So the first 3 in this problem is the tenths place. So 5 or more, add 1 more. 4 or less, let it rest. We're going to leave our 3 alone. So our answer is going to be 11.3 feet, or 11 3/10 feet. Let's learn about the Pythagorean theorem in 3D shapes. The main difference between the Pythagorean theorem in 2D shapes versus 3D shapes is we are dealing with a rectangular prism versus rectangles and squares. We have an extra side length to consider when we're dealing with 3D shapes. The formula for the Pythagorean theorem in 3D shapes is length squared plus width squared plus height squared equals r squared. R is the diagonal from one corner to the corner farthest away. That is the hypotenuse value that we are solving for. Let's go ahead and read this word problem and determine how we can solve it. A bee is in a box shaped as a rectangular prism. The box measures 30 inches by 14 inches by 40 inches. The bee flies from one corner of the box to the corner that is farthest away. To the nearest inch, how far does the bee fly? Well, let's go ahead and begin plugging in our values in place of our letters. So the length of our box is 40 inches. So we'll have 40 squared plus the width of our box, which is 14 inches, plus the height of our box, which is 30 inches. And this will all equal to r squared. Just like previously, we can type the entire expression into our calculators. 40 x to the second plus 14 x to the second plus 30 x to the second equals. You should get 2,696, and that equals r squared. But remember, we always have to take the square root. We always want our final answer to not have an exponent. So the square root of 2,696 is 51.923 blah, blah, blah. We'll stop right there. So if we look at the word problem, it tells us to round to the nearest inch. So that means we're going to get rid of any decimal places. So we're going to stop where the decimal is. So now we have to determine what that 9 is going to do to our problem. 5 or more, add 1 more. 4 or less, let it rest. Since 9 is 5 or more, we're going to add 1 more to the ones value. So 51 plus 1 will equal 52 inches. Is the length the bee will fly from one corner to the opposite corner inside of the rectangular prism. Now let's practice. Go to Pearson EasyBridge and begin working on 7.3 Math Excel Converse of the Pythagorean Theorem practice. If you feel like you need more help before you practice, watch the videos I assigned on Pearson.